Hey everyone, thanks for joining in. So this is the latest in the series of webinars around decision making. So thanks again for coming in here. Just as a quick recap, I think the first webinar that we had was around the whole ontology layer of how we actually build the entire unified causal context layer. The second was more around reasoning on how that actually enables sort of multi-hop, multi-layered reasoning regardless of the source or the structured or unstructured data that we're dealing with. Today's webinar revolves around trust in AI, which I think is the most anxiety inducing topic for every AI or data leader out there. And for today's webinar, we have Anand with us as the guest. He was gracious enough to join us. Just as a quick background, Anand today leads product at Impact Analytics, pretty much all the AI charter for retail orgs. And this includes pretty much all the well known brands that you would have heard, Ralph Lauren to Victoria's Secret to you just name one, and he's pretty much the person leading the AI charter behind them. So that's what he's up to today. But to be honest, he has been in the trenches for over decades, has led product across Plevo, ClearTap, mFine, and has pretty much seen the entire journey, right? From 0 to 1 to 100, you name it, and he's been there. So again, thanks a lot, Anand, for joining in. I think it'll be a great conversation today. So maybe we'll just first get started with a quick introduction of what we are up to, how we are going to go about the topic at hand. Maybe Ranjan sir will chime in to begin with, and then we'll dive right into the demo, go through how the trust in AI is established today, and then we'll have more of a conversation with Anand on how he has seen the whole anxiety around trust in AI evolve and how has it been solved today, so on and so forth. So yeah, over to you, Ranjan sir.
Sure. Thanks, Rishank, and welcome Anand to the podcast. Hi, everyone. I'm Ranjan, founder at DecisionX. So when we talk about trust in AI, and primarily we work in industries where at DecisionX you are solving for decision intelligence, and it's primarily for industries with high consequence decision making. And those are like the pharma, CPG, regulated industries again, where the cost of going wrong is very high. We deal with things like pharma R&D side, where you have a decision, no go decision of key molecules that you're looking to formulate, the drug discovery that's happening. So the choices that are shaping some of these, the choices that are getting shaped with some of this intelligence, essentially underlying requires a very high degree of certainty. So pretty much having dealt with it for over last a year or so, I think um, we have some perspective around it, and we want to talk about it. Can you go to the next slide, please? Yeah, so here's the two questions, right? Fundamentally, that everyone, every CIO, every CDO, everyone who is leading AI essentially is asking. First uh, is enterprise organizational knowledge IP leaking to LLM model providers? And essentially, how do I trust that you have got a system which ensures that it does not happen? Satya Nadella recently said the reverse information paradox, where he highlights the fact that essentially the model providers are learning out of organizational knowledge, and hence it's fundamental for enterprise to actually go and retain their IP and not pay twice, once in token cost and second in terms of training those models. So I think that's one of the fundamental questions that we have heard. The second very interesting question that we keep hearing is about how to trust in the response, which is given by AI, given it's a probabilistic system, and then how do you avoid hallucination? How do you ensure that there's zero hallucination, particularly in an organization where the cost of going wrong is very high, and that dwells around the question of how much of probabilistic approach and how much of deterministic approach is true, and essentially between the two will dive deeper. Um, so here's our take on the first question, which is what needs to stay sovereign and what needs to be leveraged from the model provider. So just a chronological history of last couple of years, the way it has happened. LLM came in, people went about plugging data straight up to LLMs. It hallucinated big time. Then came in agentic movement where all the agents were accelerating the workflow automation and looked good at POC, but then quickly started going burst in terms of at scale. And more importantly, what it posed is a threat that is your data and knowledge getting leaked to the model providers, and hence, essentially, how do we go about protecting? So, when you work with pharma, and essentially we look at all things from a three-layer perspective. The first is data foundation, where you have got your data, it's structured and unstructured data sitting in various kinds of systems, and we built ontology on top of it, the decision ontology, where we bring in the process understanding, industry understanding, data understanding, all of that ontology agent sort of goes about building autonomously, brings in a lot of efficiency and builds that knowledge layer that is queryable. And this part of the knowledge is where we are very particular that it should stay with the enterprise. It's an enterprise IP. It's very sovereign to them. It has to be governed by them. And then the only way data ever talks to model is through this ontology layer and not straight up to the data. It solves a bunch of things. One, it reduces your cost. Second, it creates a very strong sense of governance. Third, your answer becomes contextually very meaningful. So from all three efficiency layers, it's a winner. The other thing that we bring in is model redundancy. Uh, no enterprise should ever rely on single model. I think there's a bunch of options that is out there today, and not all kinds of query actually require same model to be accessed. So again, that's an intelligence layer that's baked into the platform, allows you to use various kind of model in terms of cost optimization, in terms of availability, as well as in terms of ensuring that you get the best leverage from the model. So as much as the first problem, which is whether my knowledge is secure or not as a company, that's primarily an engineering problem or architectural problem of how do you actually go about creeting governance and sovereignty around the ontology as a layer. So that's how we have gone about solving. This is something that we keep hearing again and again, where a pharma R&D is bothered about the fact that whether my molecule and drug formulation will go in hands of the model provider. So we take care of that concern. Go to the next one. The second problem, where how much of this is deterministic, how much of this is probabilistic. Rishan would love to rather take you can take this question and probably dive deeper, more technically around it.
Sure. So thanks a lot for that comprehensive walkthrough. I think it pretty much sums up what every AI or data leader in typically pharma or even CPG thinks about, where how much of that knowledge stays with them, how much of that goes to a model provider, how to secure that. Now, one thing that keeps coming up as we sort of dive deeper into how the architecture is supposed to work is that how do you, at the end of the day, trust an entity that is inherently non-deterministic? So, for anyone well versed with all forms of LLMs out there, autoencoders being the main ones, but even if you're talking about vision language models or if you're talking about, let's say, diffusion LLMs, pretty much all of them are probabilistic by their very nature. If they are predicting the next token or if they're predicting, let's say, the entire pixel in one go. So, the entire discourse today has been around hallucination, and this is where that problem gets layered up into, okay, now this is the part of the system that I just never want to share, want to keep with myself, but then again, how do I trust what the answer is coming in? And that is how it gets resolved into sort of the base layers, where now you don't quite know whether the answer that is coming in, how much trustworthy it is. And now for table stakes use cases, of course, you see that chat GPT or Claude disclaimer that the AI can make mistakes, so you just sort of roll around with it if it's a summary use case or if you're just writing a note or an email. But when you are taking decisions of such high consequences, whether around drug discovery, whether around figuring out if your drugs are actually compliant in the industry or not, you can't quite afford to live by that line. So the core problem boils down to that in a certain workflow of mature industries, the errors keep compounding. So if you have a probabilistic system, let's say at step one, it is working 95% of the times, 98% of the times. At step two, it is also working 95, 98% of the times. and this typically like a multi-chained workflow, by default what you would end up as a workflow accuracy would revolve around 50 or 60% of the time. So imagine taking a high consequence decision when one out of two times you don't quite even know if the numbers you are seeing is correct or not, or if the insight that you are seeing is correct or not. So pretty much high stakes decision workflows can't really run on probabilities and chance. I think Albert Einstein had once said in a different context that God doesn't play dice. So yeah, pretty much comes up here also. The core component of this is that at a model level there is no provenance that is baked in. So you have all the weights that, let's say, even open source model providers can give you, but you don't quite know what is that weight actually meaning in your context or your business or your workflow, and you're never quite able to interpret it in the way where you can tune it to your needs, or you can figure out, okay, this is what I need to provide as context for a workflow to work right. So while all of this is sort of the core problem, and I mean, pretty much been top of mind for everyone in the past year or so, I think best summed up by that single line that you really want an AI that is provably right and not just probably right. So that brings us to what we are doing here at DecisionX and how we view it. So I mean, not going too much into sort of the language aspects of it, but I think everyone would have seen some pop culture reference to, if it looks like a duck, swims like a duck, and quacks like a duck, then it is probably a duck. So, much like that, if we go deeper into sort of the CS principles that some people here might have been like already well versed in, if you look at a finite state machine, there are processes that are inherently non-deterministic. But one of the axioms with which a finite state machine is built or observed or evaluated is that there is always a sort of congruent and consequential complementary deterministic system for every non-deterministic system, and it typically compiles to that if you look at what are the paths that the non-deterministic system is taking, if you can figure out what the shape of that path looks like, then you will eventually end up with the base rules with which you can actually interpret its behavior. So that is the chief insight and philosophy, as well as the logic with which the platform has been built. And that is what eventually leads to something called reasoning trails that we have at a per query level. Now, how it works in practice is something we'll see in the demo. Just to give a high level sense of it, there is a personalization layer on the platform. So AI is used to interpret your preferences. It is used to store your preferences in the way you will probably like to view an answer or how you refer to certain terms. It then uses that, grounds it in causal ontology, and then eventually figures out what are the code paths that need to be executed deterministically. So you always know that the numbers are right, the paths are right, and the workflows are always going to be deterministic. So there's more of a high level sense. But let me now sort of dive deeper into the platform and actually show you how it works in practice. So, yeah. And by the time I roll it up, if there are any questions, happy to answer it. Okay, awesome. So, say hello to the DecisionX platform once more. And just as a quick background, here we have connectors. Of course, for people who are tuning it for the second or third time, there will be a bunch of updates that you would be noticing. So, just as a quick recap, in this particular project, what I'm going to basically show is the work we are engaging with on with like pharma companies. The numbers are right. Sorry.
No, go ahead, Shyam. Sorry.
Sure. So, as I was saying, so this particular project is sort of a synthetic representation of the work we are doing with pharma companies. Typically, in a drug discovery life cycle, there is a discovery process, there is a preclinical workflow, there are clinical trials and workflows around it. And once it is in the trial stage or out in the market, there are a bunch of compliance workflows that pretty much everyone has to be on top of. Now, one pain point that every pharma leader would relate to is that of pharmacovigilance. So, at every given point of time, if there are sort of brands that you have sold, and there are complaints that are coming in, you have to mandatorily report it within a time limit. And I'm pretty sure everyone is well versed with those mandates and what happens if you miss out on those timelines. So, in this particular project, what I've done is I've plugged together Google BigQuery and few local files. So there is essentially all of your conversation data. So like a bunch across different like regions, people, all of that. Let me just go back to connectors once more. There are safety logs. So pretty much all adverse events that would have been reported in the past, all of that logged in here directly. And the third being more of your turn logs. So essentially at every turn, what that conversation has been, if there is any metadata that needed to be captured around it, all of that coming in. So a good mix of structured and unstructured data coming in here. Now, the first thing that we do is build the ontology. So here you can see the three layers in action: data, domain, and decision. Just again, as a quick recap, you can always click on any of these concepts. So, for example, time to escalation hours, and actually see where this concept is coming, sort of coming from. What are its connections to objects, entities, other concepts? So now with this in place, we get into reasoning. So as we get into multi-layered and multi-hop reasoning, you will see some that we have laid out right here and some that you can just start off in plain text. So let me just pick one of them, let's say root cause analysis. Now, typically what tends to happen is that there are always sort of conversations that you miss out on, and they are the ones that are pretty much the costliest. So one way to know on the platform that which is one conversation where, let's say, things weren't triggered on time, you can always set signals. So this was of course part of something that we had covered in the last webinar. But just so people know that where do you actually start off on the platform from? So there is, let's say, a signal where you want to figure out what are the non-escalated calls in the last 24 hours. Now, this is something that is running periodically. And here it figures out that there is this one conversation ID conv002, which wasn't escalated within the required 24-hour window. And you notice that the escalation only occurred after quite a long period of time. And this, of course, becomes like a grave issue to look into. And you want to figure out why is this happening. So with this context, you go into reasoning. You, let's say, get into an RCA, and you want to figure out why con002 was not escalated. What are the underlying root causes? Do a full RCA. So yeah, so now the system will essentially start figuring out what is the best way to go across all the data sources that we had, figures out from the ontology what are the things to actually look at, how must the query be designed to start figuring out why this did not get escalated. So you will essentially have things that are coming in not just from the object level where it's identifying what com002 is all about, but also at a causal level on what are the properties that it is related to, what is the transcript looking like, and other typical parameters around it. Now here what the system has done, that under summarized view, it has shown that there is a safety escalation, there was a regulatory breach that is confirmed, certain snapshots around it. But how do we know that what the system has thrown is truly correct, or something that if I ask the system again, it'll actually show the same answer or not, both at a factual level and at a contextual level? And this is the part where we start diving deeper, pun intended, into deep dive. So this is the part where you can now actually see the entire rationale of what the analysis was, beginning from the key findings. So here, for example, it first identified what is the case, what is the drug and system that has been captured, what is the reporter type. So there are certain types that you always have saved in your system as tags, where the escalation requirement was breached, what does the implications of these mean for you, and typically what the data scope or confidence of this is. Now, while like deep dive will show you at a overall level what those mid data tables or states have looked like, now we get into trail, and this is the portion where you can now see how the platform actually has baked in provenance at a per query level. So the first is the whole personalization and AI layer, where the system looked through your query, figured what the chief intent is. So it wants to check whether this actually includes an adverse event, and if so, what was the driver variables around it. So what was the implicated drug, system, reporter type, any regulatory escalation requirement, because of which you ultimately ended up with a breach of at a time level. Now, basis this, the system then goes into the different deterministic paths that it had to come up with the particular analysis. So here you can actually see the assumptions it made, the steps it took. So, for example, it actually goes through that it joined the conversation to the case files. It then figured what the safety related information was present, what was the particular drugs. So, it figures out those attributes, evaluates the escalation window, and then determines the regulatory disposition. So, it's pretty much going through all the different sort of tables that was there, figures what are the join keys for it, goes through all the unstructured document, including certain compliance that already exists globally and like keeps getting updated, and then figures what the ultimate regulatory disposition is. Gives you at the end of the day what are the evidences that it has gathered to back the answer, and you can always get a sense of what the ultimate query was that was deterministically put out there. Now, what this does is that you no longer have to guess what the model was thinking. You pretty much know what every step of the model was. Is this more of a weight interpretability kind of an answer? No, because at the end of the day, what those weights mean mathematically will not make sense at a workflow level. So, what we have done is that when there is a multi agent system, pretty much every step along the way is something that gets emitted. You always have an auditable trail and you can always steer it in the direction you want. So if you want, you can go and chat to ontology to update a few things in the context if you feel so. And that then becomes a deterministic grounding again to basically go through the whole process. So this is pretty much at a per query level of how provenance is baked in on DecisionX, and this is what then translates into pretty much all of the artifacts that we have on top of it, whether that be a board, a view, a signal, even slides for that matter. So you can have certain boards that are set up where there is like live data flowing in, and you always want to figure out what the insights should be that comes out from it. But you can always be rest assured that this is something that is always coming true. And this becomes the basis of the work that we're actually engaging with some of the leading pharma brands on. And we are thankful for the opportunity that they trust us with this. And then we are able to deliver a system that is 100% factually correct. Yeah. So hope the demo sort of made the trust in AI feel a little more trustworthy, especially on platforms like us. If there are any questions, would love to answer. Else, would really want to learn more of Anand's worldviews and how he has been in the trenches, what has been his learnings, and how we can translate that here. So,
Just to add some colors to what Rishank said, right?
hmm,
Pharmacovigilance is a regulatory mandate
hmm,
for a pharma industry where if there is any complaint from from a prospective patient or a customer,
hmm,
within 15 hours it is mandated to be reported. And companies which does not do that can have very heavy penalties. So again, a decision which is very consequential. Now think of thousands of call feedback that might be coming, and all those conversation as unstructured data needs to be analyzed and within 15 hours needs to be reported. So if something is not reported, it's a substantial violation in compliance. So again, a decision or a intelligence which is very consequential. And beyond compliance, it's also about how do you understand if there is any adverse reaction to a certain drug that has gone out in the market is happening. And if you miss out, like missing out one is consequential, right? Like one person might get affected by that one thing that has not got picked up. So as much it is compliance, it's also like real life impact, right? In terms of what it can lead to in terms of fertility. So that's just one example of when industries like pharma, like CPG, some of the things like research and development or a new product development, if they when they trust us, the trust is grounded in the fact that the system must not be a black box. And essentially, you should have grounding and auditability and traceability and explainability at all points in your queries. So that's just additional some color I thought I'll throw. But over to you, Rishank.
sure, sir. So, yeah, maybe I'll just stop sharing the screen and we can get that whole spotlight on Anand now. So, so yeah, thanks again, Anand, for joining us. And I think I actually had asked for a bunch of questions to our near and dear ones before the webinar, so I had a few handy. Maybe we'll pick like a top three, top five of it, depending on the amount of time that we have, and we'll go through it. But I think one of the chief requested ones was to understand more from an operator and sort of practitioner point of view. That, I mean, you have been working with pretty much all the known retail brands out there.
Yeah.
I mean, one of those areas where again things when they go wrong or there is any sort of discrepancy, there is like a bunch of lives that get hit in a lot of multitude ways. uh, so the first question, Anand, is typically that, right? So in retail and the work that you have been doing over the past few months, years, um, what do you think is the chief difference between AI that just works in demos, looks flashy, versus AI that actually works in like complex environments in production? So would love to start off from there.
Yeah, that's quite a good framing, because we all have experienced as seasoned tech professionals. When we demo the AI features, it sells quite well, but in
Hmm.
production, it uh, fails even that spectacularly, right?
Yeah.
We had similar experiences in the past, so we know better now, right? So let me start with me explaining what is the challenge that we solve.
Hmm.
So in retail or in large org retails, which has multiple stores across the globe, right?
Hmm.
And we are talking about 2000, 2500 stores
Hmm.
with a lot of different departments, divisions of clothing all being sold, right?
Hmm.
Um, People want accuracy when they expect what was the sales for kids division in the swimwear category, for example.
Hmm.
Right. Now, as a business intelligence tool, like you would expect with Power BI or Tableau,
Hmm.
accuracy becomes of key importance because one wrong data can
Hmm.
change the business decisions taken from there, right? And that's where the accuracy part and the trust part of the AI that we build comes into play. And
Hmm.
whenever we talk about trust, I think very soon the needle moves to deterministic and non-deterministic, the arguments, right? So let me touch upon that, right? So for the uninitiated and whosoever has been joining for the first time or looking at this discussion for the first time, whenever you go to Claude, start building an agent, you
Hmm.
will invariably build a non-deterministic agent,
Yeah.
right? You ask the same question twice, it will probably give two different answers, right?
Hmm.
In real life or in production or in high stake scenario like yours,
Hmm.
this won't work, obviously, because we need accuracy to the T. Any inaccurate answer might cost a life in case of pharma, right?
Hmm.
So here, I think main thing becomes is how we separate what the answer is versus how it is communicated, right? That becomes most important, and the architecture that we follow um, at Impact and what I've seen in DecisionX as well is you don't give all the power to the LLM itself, right? LLM does its part, and then the deterministic flow also does its part. So probably the first, whenever the question is asked, let's say, how did the sales happen in the Northeast region, for example, right? First is the agent needs to detect the intent. What is this user even trying to ask? Probably he is saying sales, or maybe the user can be very ambiguous. How did this perform? How did the New Delhi perform, for example, right? What does performance mean? So the agent's responsibility is to use non-determinism to understand what the context is. How does it relate to on the ground objects? For example, performance means sales. Delhi means all the stores in Delhi, right? And he's probably asking for the overall sales and not for some department. All of these things the agent should be able to capture and pass it on to the next level, which is the second level, which is again the deterministic workflows of writing what kind of SQL has to be created for the query to run on the database. So essentially, what we have done is we have gotten the intent, we have written the code that finds out the actual data, which is mathematically correct, which cannot go wrong because even if you run it 100 times, it will give you the same data. Once the data comes, we have the answer, we knew the intent, so the answer is correct. Now the last part will be the summarization or reconciliation of all the data points into a coherent sentence so that it sounds human. I think that is what the whole flow and what you also showed, Rishank, makes an agent actually human and accurate as well in the same breath, right? So that's the kind of framework to build a trustworthy agent, quote unquote, so to say.
No, makes sense. I think that sheds a lot of light on both the architectural aspects and the end user worldview, right? I mean,
Yeah.
uh, just sort of going to an agent, asking a question, and then just getting an answer that is not making sense, sounding robotic, or maybe goes haywire, where it starts to let's say optimize a plan where it's just by default never going to happen. I
Yeah.
think
Yeah.
these are the aspects that you sort of tend to skip over and sort of stay on ground, as some would say, when it comes to building it this way. Makes sense. I'm actually glad, Anand, that you started to touch a lot upon the architectural aspects, and I'm sure that as you would have gone about building agents across a wide variety of problems and domains as well. Um, where do you think, from all that you have known, experienced about DecisionX, is the delta in our platform today? So, I mean, there is the whole ontology piece, there is a reasoning, there are ways in which Trail works, and there are certain things that you have been able to see as one of the design partners from before. So, where do you chiefly see the delta lie in DecisionX today?
So I think what decision X, the delta was in the decision to build a ontology or a causal layer, right? Which becomes the soul of all the responses that comes out of decision X. Um, so just for the again uninitiated, right? What causal graphs are essentially is essentially a graph of different objects who are connected with each other and how they are connected. So in my retail terminology, I'll say that, let's say if the question is asked about sales, I would relate sales to what all factors is affecting sales. It can be number of units sold, it can be what was the pricing or the discount on that product, it was how many people have visited the store that day, it can also be what was the weather on that day, right? So I can go on and I can have a lot of factors. I can have a bunch of limited factors. But what causal graph here is doing is it's kind of limiting the LLM's capability of going overboard, right? An LLM, if given free rein, will kind of try to figure out some random hallucinated reasons, which might sound very fancy, but might not have any substance. What the causal graphs actually do is keep the reasoning very professional, which becomes even more important for your use cases like pharma, right? So there are two benefits actually. One is, like I said, it keeps the reasoning very grounded, very professional. How actual pharmacists will behave like. And the second is, once and response has been given, it helps you backtrack how the decision was made, which all factors were considered, which what are the weights that was there that made it consider this factor over that factor, right? That eventually adds up to the trust layer of the whole system, and that's what I think what DecisionX gets it right, right from the day one, right? So that's what I think would be the exact delta why DecisionX shines in these use cases.
Oh, makes sense, Anand. I mean, thanks for that.
Yeah.
I'm glad that the worldviews align in that aspect. I think this actually leads me to that question, right? Which is more getting into the minds of people who are now actually implementing AI in the trenches. So even if, let's say, you have a system that promises you deterministicity, it
Mm.
promises you backward traceability, which I think is, of course, super important. One of the chief anxieties that pretty much every AI data leader has in a complex org is change management. And change management, of course, has different forms, becomes complex as you go through hierarchies, becomes complex as the degree of real world element keeps increasing. So with all the work that you have done, especially with the likes of, let's say, Ralph Lauren,
Mm.
how does this dimension of change management gets handled today? And what, in your worldview, are sort of the best practices that an AI or data leader can actually look into,
Yeah.
especially as they think about bringing vendors on board because they want to, but they are, I think, lacking a lot of mental models when it comes to change management, just as this whole beast
Correct.
to tackle with. So,
Correct. Yeah, so working with these heritage retailers, I'd say, right, who have
mm,
been in existence for almost decades, they are also trying to get onto the AI bandwagon. And I would like to point out a very specific challenge that I have seen when we go ahead and pitch them AI-based solutions. Is I'll give you a scenario, right? If today I go and ask 10 members of let's say Ralph Lauren a question that how did dress do last week, or how did dresses perform last week, for example, right? What does dresses mean? If I ask a merchandiser, he will give me a different answer. If I ask an inventory manager, he will give me a different answer. And it's very much possible a store manager will also give a different answer. So, what does each and every term mean for the org? That becomes very important. And that's where I would like to go back to the ontology layer, right? An ontology is essentially nothing but defining what each and every term means and how it matters in the whole context of the org and to the overall goal that the AI is going to achieve, right? And that becomes the key element here. Now, now that we have defined ontology, the key challenge that we have seen is getting the whole department or whole business unit who is going to use this AI system to agree on what the ontology should be. Like what should dresses mean for everyone should be the same, right? Uh, how do you calculate, let's say, markdown? How is markdown different than a discount, right?
mm,
I have seen today in today's meeting, I was meeting with one of the European clients, and two different departments had different views of their own, right? Which is now coming to light because we are putting AI to their org, right? That is what I would say the change management's real challenge is. So I'd say ontology becomes a very important thing, right? Once you build the ontology, once you build the whole layer of what means what and how AI will consume it, it's 70% of the work done. The rest 30% is building harnesses, building multimodality, and all those things. But I think what you have done for this pharma company, building that ontology, that is like the hardest challenge that we have seen. So yeah, that is what I'll say, right? Getting the ontology right is 70%. Rest everything is kind of the easy work.
makes sense. Makes sense. I think.
Anand, I have a question. I
Yeah,
think this
yeah,
is more like what I keep hearing from a lot of customers, particularly senior leadership. How do you know that uh, ontology is right? Means ultimately, if everything boils down to the fact that
yeah,
it's about ontology and how it's built, how exhaustive it. So one is more from how exhaustive it is, and second, even if it is accurately mapping the relationship. So I'm sure that there's a lot of systems upcoming in terms of eval of ontology and whatnot.
yes,
What's your take on that, and what's recent that you have seen, heard around the best way that people are tackling around this problem?
yeah, right. So we have had these questions from our customers as well. Uh, so the curious case is for us, every customer will have a different hierarchies, different terminologies. Let's say somebody calls it division, somebody calls it department, somebody calls it categories, right?
Hmm.
However, the structure of how retail works is more or less the same, right? There will be two dimensions of product hierarchy and store hierarchy, and both will have products and the sales and KPIs will be calculated on top of each other, right? Having
Hmm.
said that, what we rely more on is domain expertise, right? Uh, we have people from across the globe who have worked on these retailers with these retailers, and they kind of suggest what should be the ideal hierarchy. And then we also work with, so essentially when we are doing onboarding with one of these retailers, let's say it's a new customer onboarding, we would have some spend some time, like 2 weeks of time, discussing how to design this whole ontology so that what you expect out of the AI agent is in line with what your business units also want to see, right? So basically, it's twofold, right? We first use our domain expertise to build a 80% version, and then the 20% is chiseled out during the onboarding design sessions.
Got it. No, so we approached it very similarly. I think when we look at ontology, we look at data ontology, we look at domain ontology, and then we look at process ontology. So all of that brings together. And essentially, unless you don't have the know-how of the industry and domain, you are again another data product, which might or might not mean the significant outcome the way you expect. And one of the ways in which we have seen this playing out is actually in terms of adoption. When a lot of companies actually talk about adoption, the buyer and the end user is very different,
Yeah.
right? So the end user goes about solving business problems, business as usual, AI or no AI. And the moment you hand over a solution which actually does not talk the domain language, then they are like, okay, this is probably very surface level and I can't use it to the extent. And then it classically leads to the adoption problem. So yeah, you rightly touched upon that domain expertise, and then that specific aspect sort of comes in very handy. So just last question on that now. Um, when I think when it comes about something like domain ontology, right? Like we approached it a little differently. That while it's a knowledge, it's a decade of knowledge that we are trying to ingest and get it all together. We also see that when a query is being asked and there is eval of at a query response level, whatever things is coming in, what is the best mechanics that you have seen in terms of people validating for, okay, this is a system that is deterministic. One is saying, okay, I sitting in higher chair can say that, versus how an end user is able to get that confidence. And given that we're talking about trust in AI, essentially, uh, means one is it might be great answer. Yes, I have a great technology, but how does the other guy believes it, and what's the smartest, fastest way of actually absorbing and sort of concluding that?
Yeah. So, what we essentially do behind the scenes is, like I said, right, our architecture is detecting the intent. Basis the intent, uh, we run the query on the database and we get the answers, right? Now, what we do is, after the response has been given, um, we run another sort of one layer of check, saying what is the confidence on this response, right? It can be a separate agent as well, who is reverse tracing. Like if I have gotten a query generated, it just reverse traces whether the answer in this query is actually matching the original intent that was asked. And that is again a non-deterministic process, right? And based on that, it assigns a confidence percentage, that okay, I'm 80% confidence, I'm 100% confident. Sometimes, so for example, when will the AI agent be, let's say, 20 or 30% confident? When you ask a very ambiguous query, the intent detection does a lot of work here to identify what could be the intent, what are the essentially departments or divisions he's trying to mean, and it prepares an SQL, right? However, the confidence is low because it has done a lot of thinking itself. You have not given very specific instructions, right? So that is one way we are doing it right now. We just publish a confidence number, and we also take a immediate feedback from the user whether he thinks the response is right or wrong, right? That is one, and then we also do evals where we are doing tracing and scoring and both offline evals with 200 question golden data set and online evals, which is on runtime, right? So yeah.
Oh, thanks a lot. I think super helpful. One of the approach that we actually took was that for every query, at least while building ontology and as we are running the evals, we run the answer by model and then in the good old probabilistic way, deterministic way. Essentially, mathematical answer versus a AI answer. You look at delta at a query level to really see out of 200 times how many times I'm consistent. Because the question and challenge was always of the ground truth. What do you understand? What do you establish as a ground truth? So no, I think fairly comprehensive answer. I hope our audience sort of understood and sort of can leverage value out of this conversation. Vishank, over to you.
No, makes sense. I think I really like the sort of that part, right, where there is a generator model and there is sort of a discriminator model, and then you are just sort of getting both of them at a war front to figure out what is the correct truth. A lot of sort of mental puzzles have been built on that. But yeah, I mean, to be honest, the way we look at evals, the way we look at ontology is a lot from the topological nature of an answer. If that shape matches, then things would match downstream of it. Things that we do a little more to establish trust is the deterministic part, as Ranjan sir was mentioning. Takes a little bit of time, but we call this pass-wise accuracy. So, given the same query, if it is passed once, twice, thrice, four times, and sometimes across models, depending on the kind of customers that you're working with, what does pass one accuracy look like, all the way down to what does pass four accuracy look like, and that also feeds back into the ontology where if there is a divergence, then we use that as sort of our business rules. But yeah, I think to be honest, today's discussion around trust in AI would have been would have been really helpful for a lot of practitioners out there, and of course for senior leaders also as they look to evaluate what is the kind of AI they want to bring into their their world, and how do they actually trust what is being talked about. So yes, I hope it was a fruitful discussion for everyone, and we hope to see you in the next webinar. Uh, okay.
Thanks a lot, Rishank. Thanks, Anand, for joining. Thanks a lot for your time.